Hello my dear friends, now I'm going to explain you chapter number 5. The name of the chapter number 5 is partial derivative. I will try to explain you step by steps what are the meaning of partial derivative and how we can find or how we can write the first order partial derivative. So before going to start, just I want to tell you that if any function is written as like z is equal to f of x y, then we need to check that what is here x and y and what is here z. So if it is given like that, it means that this x and y, these two x and y called independent variable and z is called dependent variable. When any type of function which is written as like that, I mean z is equal to function of xy, means two or more than two independent variables are involved and one dependent variable, then when we try to write the derivative, it is called as partial derivative. Means suppose if I have this type of function y is equal to f of x, means if I have y is equal to sin x, example of that one, if I say find dy dx, so dy dx means it is equal to cosine of x. That means find the derivative of this y is equal to fx function. Here you see that one, this fx, that means here x is here independent variable. Fx, that means x is independent variable. Independent variable, and this y is called dependent variable. This y is called dependent variable. When any type of mathematical relation given as function y is equal to fx, that means one dependent and one independent variable, and if you try to find the derivative like dy dx is equal to cosine x, it is called ordinary derivative. Ordinary derivative. Ordinary derivative. If you write first, that means dy dx, it is called first order derivative. If you differentiate again, it is called second order. So we will discuss according that first order partial derivative according to that one. Now see that one is z is equal to u of fxy, that means this z dependent variable and xy is independent variable. Now if it is given as like u is equal to f of x y z, that means x y z, these three terms x y and z, x y and z are independent variable. Independent variable, and u is called here dependent variable. If I try to solve or if I try to find the derivative of this type of function, it is called partial derivative. So I am just giving to you one example by picking one example from the booklet. This is an example which I picked from the handout. If f of xy is equal to ln of x square plus y square, find del f del x and del f del y. That means first order partial derivative. That means find the first order partial derivative of f with respect to x, f with respect to y. That means f is function here. So here see that one, how many independent variable we can check from this function f of xy. That means x and y, these two independent variables. Independent variables. So what we have to do, I want to ask, he is asking that find del f del x, first order partial derivative of this f function with respect to x partially and f function with respect to y partially. So now I am going to do that one. Del f del x. So del f del x means with respect to x. If del f del x means partial derivative of f with respect to x, it means you have to keep y as constant. So see that one here. I want to use here, there is one rule which is called chain rule. Dx of ln of u is 1 divided by u into du dx, ddx of u. Using this one, see that one here, ln of u. Here, see that one here. If you observe that here, u is equal to given x square plus y square. So just put that one. 1 ln of u. U means x square plus y square. So 1 divided by u. That means 1 divided by x square plus y square into del x of y. I am writing x because of he is asking with respect to x. Del x of u. U means x square plus y square. So write it, 1 divided by x square plus y square, and del x of x square plus y square means 2x. This is your del f del x with respect to x. We can write del f del x as del f del x, or we can write f of x. F of x is equal to this one. This is the answer of that question. Now, if he want to ask that what is the next derivative? What is the next derivative? So how we can write that one? Now we can find the next derivative. We can find the next derivative, that means del f del y. We can find the next derivative del f del y. Del f del y is equal to, del f del y is equal to, del f del y is equal to, just differentiate with respect to y of this function. So again we have to use this one. So see that one here, again ln of u. U means again x square plus y square. So now you have to keep x as constant. So 1 divided by u, that means x square plus y square, and del y of x square plus y square. So on keeping this one, f, we can write it f of y, that means del f del y is equal to 1 divided by x square plus y square, and del y of x square plus y square, that means x is treated on constant, so that derivative of x square with respect to y partially is 0. So it becomes 2y. So this is your answer of del f del y. That means this one is that part, del f del y, or we can say f of y, del f del x, or we can say f of x. F of x means here subscript. F of y means y is treating as subscript here, not multiply. So this is that answer. Now I am going to discuss how to find del f del x and del f del y of this function. That means find del f del x and del f del y. This is another question of the exercise. So what we have to do, see that one here again, f of xy, that means x and y be two independent variable. Xy is called independent variable. So what we have to do, f of x, that means partial derivative of f with respect to x, treating y as constant. So see that one here, x plus y divided by. So we need to use here the rule by division form. D dx of u divided by v is v u dash minus u v dash divided by v square. We have to use this rule here. Now see that one here, this is x plus y, that means u, and xy minus 1, that is v. So what we have to do, v means xy minus 1, and del x of the u dash, del x of x plus y, this is u dash, minus u, and then del x of v means x y minus 1, divided by v square, that means xy minus 1 power 2, xy minus 1 power 2. So now simplify, that means differentiate it. So it is coming xy minus 1 and del x of x plus y, del x of x is 1 and del x of y is 0. So this is 1 minus x plus y, del x of xy, that means y, because of y is constant, and del x of 1 is 0, divided by x y minus 1 power 2. This is your del f del x, or we can say that one f of x. So just need to simplify it. So therefore f of x, that means del f del x is x y minus 1 minus, open the bracket, so minus xy minus plus minus y square divided by xy minus 1 power 2. Now check that one, we can cancel something, xy plus and xy minus, so it is minus, that means finally f of x equal to minus 1 minus y square divided by xy minus 1 power 2. This is your del f del x, that means f of x. Similarly, we can write del f del y. So use again del f del y, means again same rule, that means division rule, del f del y. Now treating x as constant, so xy minus 1 del y of x plus y minus x plus y del y of xy minus 1 divided by v square. That means xy minus 1 power 2. Now step by step simplify it, means find the derivative. So it is xy minus 1 and del x of x plus y, that means 1 minus x plus y, and del y of xy means x, and del y of this one is 0. So it is x only divided by xy minus 1 power 2. This is your f of y. So simplify, that is your final answer. So open the bracket, xy minus 1 minus x square minus xy divided by xy minus 1 power 2. So again this and this cancel. So final answer f of y is minus 1 minus x square divided by xy minus 1 power 2. This is your f of y value. This is your f of y value by using partial derivative. Now I am taking another example from the handout, that is f of xy is equal to e power x plus y plus 1. Find del f del x and del f del y. So see that one, for that we need to use this rule, d dx of e power u is equal to e power u into d dx of u. So if you know what is the value of u, you can write the derivative of this one. So I am going to write that one, del f del x, that means y will be treated as constant. So here see that one, e power u, u means here x plus y. So here u is equal to x plus y plus 1. So e power u, and then del x of x plus y plus 1. So simplify it, When you try to simplify, what is coming? See that one here? What is coming? It is f of x is equal to e power x plus y, and then del x of x is 1. This is 0, this is 0. So simply 1. Similarly, we can write f of y, same value, e power x plus y plus 1. This is the answer of that question. Hopefully you people understand. Now I am going to tell you that if this type of function is given, then how we can write the answers of that one. That means, see that one here. In this example, x, y, z, that means x, y and z. 3 independent variable here. 3 independent variable. This function is attached with 3 independent variable. So what he is asking, find f of x, f of y and f of z. So what if this means? F of x means partial derivative of f with respect to y, treating y and z constant. So now I am going to check what is del f del x, because of 2 other variables are constant, y, z here constant. So see that one, del x of 1, 0, plus del x of x is 1, y square is constant, minus this full constant. So total answer is del f of x is this one, and del f of y, now x and z is constant. So del y of 1 is 0, plus see that one, x is constant, and then del y of y square is 2y, and this is also constant. So total is 2xy, and finally del f del z. Del f del z means x and y constant. So 1 constant, xy constant, minus 2z square, that means 4z. So total is minus 4z. These are the answers of that question when 3 independent variables are involved with 1 dependent variable. So we can write the derivative like that form. We can say that when del f del x means f of x, del f del y means del f del y means f of y, del f del z means f of z. This is the abbreviation short form to write the that type of symbols. Now another type of example from this one is this. If f of x, y, z equal to this, then how to find that? For that one, that means we need to find f of x, f of y and f of z. For that, again we need to use chain rule. D dx of ln of u is 1 divided by u into d dx of u. So if you know what is the value of u, then you can write the derivative of this one. We can write the derivative of this one by using that chain rule. We can write the derivative of this one by using chain rule. D dx of u. D dx of u. Now just I am going to check that one, del f del x. That means again y z constant. So 1 divided by u, that means x power 3 plus y power 3 plus z power 3 u, and then del x of x power 3 plus y power 3 plus z power 3. See that one, u. So see, with respect to x, that means y treated as constant and z also treated as constant. So z constant and y constant means derivative of that term will be 0. So now just write that 1 divided by x power 3 plus y power 3 plus z power 3 into del x of x power 3 means 3x square. This is your f of x. Similarly, we can write f of y by using this way, 3y square divided by x power 3 plus y power 3 plus z power 3, and f of z is 3z square divided by x power 3 plus y power 3 plus z power 3. This is the answer of that question by using chain rule. Hopefully you understand. Now I am picking another example from that one. If f of x, y, z is equal to this e power minus this one, so again we need to find f of x, f of y, f of z. So see that one, if you know only one term, we can write another value. For that, again just I want to tell you that we can use d dx of e power u, which is called nothing but chain rule, e power u into d dx of u. By using this rule, we can find the partial derivative of this function very easily. So see that one here, u is equal to minus times of x square plus y square plus z square. So f of x means e power minus x square plus y square plus z square, and then del x of minus times of x square plus y square plus z square. So just nothing, we have to differentiate it, and whatever we have, that one is my final answer. X square plus y square plus z square, and del x of this with respect to x, y constant and z constant. So del x of x square with this, so minus 2x. So this is our f of x. Similarly, we can say that f of y is minus 2y e power minus x square plus y square plus z square, and f of z is minus 2z e power minus x square plus y square plus z square. We can write similarly by using this concept and by using chain rule this answer also, I mean f of y and f of z. Now I am going to tell you how to find second order partial derivative. Second order partial derivative is nothing but it means that second derivative. That means if I have y is equal to x square plus 2x, if I say find derivative, so dy dx is equal to 2x plus 2. This is first order derivative. If you write d2y dx2, it is 2x. This is called second derivative. Using that concept, I want to discuss second order partial derivative. Second order partial derivative means del to f del x square. This, see that one, 2 times derivative. So before going to start, just I want to tell you that one, how we can write del to f del x square. Del to f del x square means del x of del f del x. That means write the partial derivative of f function with respect to x. Whatever you got, again differentiate partially. This is del to f del x square. Similarly, del to f del y square is del y of del f del y. Find the partial derivative of the function with respect to x, y, and then differentiate again. That is your del to f del y square. That means second order partial derivative. And this we can say that find the partial derivative of this one, and del to f del x del y, we can use del x of del f del y, or we can use del y of del f del x. Both have the same meaning. It means that if you know del to f del x del y, then we can write del to f del y del x, because of both have the same answer. So instead of writing 4 answer, we can use only 3, and then we can write the derivative directly of the function 4th answer. So now I am going to tell you how we can write these second order partial derivative. So the function is given here, f of xy is equal to this. So write first del f del x, because of if you want to write del 2f del x square, first you need to write del f del x. So del f del x means with respect to x partially, y should be constant. So again we have to use chain rule. So 1 divided by 2x plus 3y, and then del x of 2x plus 3y. So see that one, just 1 divided by 2x plus 3y, and del x of 2x plus 3y means 2, because of y is here constant. So this is your del f del x. If you want to find del 2f del x square, what you have to do? Just del x of del f del x. Del x of del f del x means del 2f del x square. It means again differentiate this one with respect to x. What is that? Del x of 2 divided by 2x, 2 divided by 2x, 2 divided by 2x, divided by, that means del f del x, del 2f del x square is, sorry my dear, del 2f del x square is del x of del f del x. So what you have to do? Del x of del f del x means 2 divided by 2x plus 3y. It means that you have to differentiate by using u by v method. So what you have to do? Just u into del x of v, that means 2 means 0, minus u del x of 2x plus 3y divided by v square, that means 2x plus 3y power 2. 2x plus 3y power 2. Now just simplify it. It means del 2f del x square is equal to this multiplied by 0 is 0 minus 2 times del x of 2x plus 3y means only 2 divided by 2x plus 3y power 2. So it means that del 2f del x square is minus 4 divided by 2x plus 3y power 2. Now similarly we can write del 2f del y square. For writing del 2f del y square, first of all we need to know del f del y. So del f del y, again see that one, what is the function? ln. So that means 1 divided by 2x plus 3y and del y of 2x plus 3y. So simplify it. It means del f del y is equal to, see, del y of 2x plus 3y means 3 divided by 2x plus 3y. If you want to write del 2f del y square, it means del y of del f del y. That means del 2f del y square. What is that? You need to differentiate del y of del f del y. Del f del y is this one, 3 divided by 2x plus 3y. So again you have to use division rule. That means del 2f del y square. Similarly we can say that one, this term is 0 multiplied by y constant 0 minus 3 and 3, that means minus 9 divided by 2x plus 3y power 2, or del 2f del y square is minus 9 divided by 2x plus 3y power 2. This is second derivative, that means del 2f del y square. Now I need to write del 2f del y, del 2f del x del y. So whatever. So now I am going to check what is del 2f del x del y. So, or del f del y del x, no problem. We can say that del x of del f del y, del x of del f del y. It means that del x of del f del y, del f del y, I have del f del y is what? 3 divided by this one. So 3 divided by 2x plus 3y. Now differentiate this one with respect to x. So when you differentiate this one, you have to use u by v method. So u by v method means del 2f del x del y is equal to u v and then del x of 3 minus 3 del x of v 2x plus 3y divided by v square divided by v square. That means 2x plus 3y power 2. Now simplified, it means it gives us del 2f del x del y is equal to del x of 3 0. So that means this comes 0. Del x of 3 0 minus 3 del x of 2x plus 3y means 2 divided by 2x plus 3y power 2. So now just simplify it. So we will get del 2f. It means that del 2f del x del y is equal to minus 6 divided by 2x plus 3y power 2. Similarly, knowing the third part, we can say del 2f del y del x is minus 6 divided by 2x plus 3y power 2. This is the answer of that question.